Good afternoon. We're about to continue. Raise your hand if you're able to hear me clearly. That's good enough. That is good enough. Okay. So prior to the lunch break, we looked at the respiratory system. The next system to be reviewed is the circulatory or cardiovascular system. Cardiovascular system has three components. So you have the heart, which is a pump. You have the blood vessels, which are the pipes, and you have the content, which is the blood. And the composition of the blood is fairly straightforward at this level. The blood is composed of plasma, which is a fluid portion of the blood, platelets, which is important to the clotting process, white blood cells, which are important to the immune response and fighting infection, and the red blood cells, which are essential to the process of oxygenation. So that's the composition of the blood. What we're going to look at this afternoon is the blood vessels, the layout of the blood vessels. So you need to have a good understanding of the blood vessels before we can look at how blood is circulated within the body. So we have to have a good understanding of the blood vessels. So while you were on break, I utilized the whiteboard to do up a little layout of the blood vessels. So you have the Vena Cava, veins, venules, capillaries, arterioles, arteries, and aorta. Now, the circulatory system has a side that is responsible for high pressure and a side that is responsible for low pressure. Right? So there is a high pressure side and there is a low pressure side as well. The high pressure side is the arteries, and the low pressure would be the veins. So the high pressure side is the arterial side of the circulatory system, and the low pressure side is the venous side of the respiratory system. So the first, now let's look at the blood vessels individually, starting with the low pressure side. So the Vena Cava is the largest vein in the body, and it has an inferior portion and a superior portion. Superior portion receives blood from the upper portion of the body. The inferior portion receives blood from the lower portion of the body. Right? The venules are the smallest. So venules are the smallest veins in the body. So the vena cava breaks down to veins and then it becomes venules. Now, I probably need to remove this. Let me remove this for a sec. So the vena cava is the largest vein in the body. It has a superior portion and an inferior portion. Superior receives blood from the upper portion of the body, and the inferior receives blood from the lower portion. The venules are the smallest veins in the body. Now, the veins, all veins in the body, carry blood towards the heart. So the veins carry blood toward the heart. All veins carry blood towards the heart. You have a question, Mr. Sewell?
No, sir. Sorry about that. That's an error. Sorry about that.
So veins carry blood towards the heart. And the blood that the veins carry primarily is deoxygenated blood. So the veins primarily transport deoxygenated blood with the exception of the pulmonary veins. Why people keep, is there a question, Mr. Barnes? This is very distracting. Where was I? Oh, right. So the veins primarily carry deoxygenated blood with the exception of the pulmonary veins. So the pulmonary veins actually carry oxygenated blood from the lungs to the left side of the heart. And that's the important aspects of the vein. So the largest vein, vena cava, has an inferior, superior portion. The inferior collects deoxygenated blood from the lower portion of the body. Superior portion collects deoxygenated blood from the upper portion of the body. The vena cava eventually breaks down into veins and then becomes venules. The venules are the smallest veins in the body, and the veins carry blood towards the heart. So they bring blood towards the heart. The veins primarily carry deoxygenated blood, with the exception of the pulmonary veins, which carry oxygenated blood from the lungs to the left side of the heart. Now, the veins also have valves inside of them. So there are valves located inside of the veins to prevent backflow. And that's the purpose of the valves. It prevents the backflow of blood in the wrong direction. You have a question, Ms. Kerr?
Yes, sir. You said that the pulmonary vein carries oxygenated blood to the left side of the heart or to the left side of the body?
Left side of the heart.
Okay, sir.
Right?
Thank you.
So it's going to carry it to the left side of the heart, specifically the left atrium. Then the heart will pump that blood to the rest of the body, which we'll go into that more tomorrow. So again, the veins have valves, and the purpose of the valves is to prevent the backflow of blood in the wrong direction. So that's the veins. Now let's look at the arteries. So you have the aorta. So you have the aorta, which is the largest artery in the body. You have the ascending aorta and you have the descending aorta. The ascending aorta transports blood, and this would be oxygenated blood to the upper portion of the body, and the descending aorta transports oxygenated blood to the lower portion of the body. The aorta eventually breaks down into arteries, and then the arteries become arterioles. Arterioles are the smallest. So arterioles are the smallest arteries in the body. The arterial side is the high pressure. So the arteries primarily transport blood away from the heart. So the arteries primarily transport blood away from the heart. However, there is an exception. So the coronary artery, which originates from inside the aorta, is the artery that supplies the heart muscle with blood. So it actually transports blood to the heart muscle. So that's the exception. But primarily, the arteries, A is for away. They transport blood away from the heart. Now, the arteries primarily transport oxygenated blood. So they primarily transport oxygenated blood, with the exception of the pulmonary arteries. So the pulmonary arteries carry deoxygenated blood from the right ventricle to the lungs for it to be oxygenated. Go ahead, Mr. Jones.
Afternoon. What is the name of that artery that takes the blood to the heart muscles?
Coronary artery. Right, so the coronary artery supplies the heart muscle with blood, and that's the artery that is going to be affected if a patient develops a heart attack. All right. Is there anything else I need to mention on the artery? So I've mentioned the largest, the smallest, the direction of blood flow, the type of blood that's transported. Yeah, I think that's it. So again, the arteries primarily transport oxygenated blood. However, there is an exception. The pulmonary arteries. I have 2 pulmonary arteries, 4 pulmonary veins. The pulmonary arteries transport deoxygenated blood from the right ventricle to the lungs. Yes, Mr. Graham, go ahead.
Yes, sir. Afternoon. Is it safe to say that pulmonary arteries and veins basically reverse the roles of their main role then? Is it safe to say that? Since
If that, go
yeah,
ahead.
the main function of the vein is to take the oxygenated blood from the body, the lower part, the inferior section of the body to the heart. Right? And
Yes.
the main function of the artery is to take oxygenated blood from the heart to the body. Exception of the both pulmonary artery and the vein. So they basically reverse roles.
be careful with the term reverse,
Oh,
right? Because they, right? So just be careful with the term reverse. The arteries, even though the pulmonary artery is transporting deoxygenated blood, it is still carrying the blood away from the heart, right? So it's still moving the blood away from the heart. It's just moving it to the lungs where it can be oxygenated.
okay, I understood, sir. Understood.
You understand what I'm saying? So,
Yeah, understand. Thank you. So that means that the pulmonary vein would be carrying the oxygenated blood towards the heart from the lungs.
correct,
Okay,
correct.
understood. All right.
Good. All right. Now, it's very important that you understand the direction of flow for the vessels and the concentration of oxygen in the blood. Now, the capillaries. The capillaries are the smallest blood vessels in the body. So the smallest blood vessels in the body are the capillaries. And the capillaries are an important aspect or area of the blood vessels. Because if you can look on the layout that I have on my whiteboard, you will see that the capillaries is the connection between the smallest veins in the body and the smallest arteries in the body. So it's the connection between these vessels. And it is at this point within the circulatory system that the exchange of carbon dioxide and oxygen will occur. So you have capillaries that wrap around the alveoli, pulmonary capillaries. I have cellular systemic capillaries. Now, at the level of the capillaries, it is one cell at a time. So only one cell can move at a time, one cell at a time. And depending on where the capillary is, so if it's coming from, if it's the venous side, when it get to the capillaries, the cell will pick up the oxygen, right, and become more oxygenated, and then it crosses over to the arterial side. So capillaries, smallest blood vessels in the body. It's the connection between the smallest veins, which is the venules, and the arterioles, which is the smallest arteries. And at this point within the circulatory system, we get the exchange of carbon dioxide and the exchange of oxygen. So everything I have explained to this point, you need to ensure that when you come to class tomorrow morning, you understand that concept or the concepts I just explained to you. So you need to know which side is low pressure, which side is high pressure. You need to know which side carries deoxygenated blood primarily and which side carry oxygenated blood primarily. And you need to know the roles of the capillaries. And most persons that cover the circulatory system when they're studying it, they often neglect the capillaries, which it's the connection point. It's a closed network. So if you don't understand what is occurring at the capillary level, you're going to get confused. So you have to see the connection and then understand how the exchange occur. And we'll go deep into that tomorrow. Are there any questions? Is there anything that I need to repeat? Go ahead, Mr. Graham.
So yes, sir. So capillaries are specifically situated in the heart, or they're just at where any of the veins and arteries meet.
The capillaries are found around the alveoli. So you have pulmonary capillaries, which are wrapped around the alveoli. And that's actually the breakdown of the pulmonary arteries. So the pulmonary artery, which transports deoxygenated blood from the left ventricle to the lungs. When the pulmonary artery is moving that deoxygenated blood, eventually the pulmonary artery will break down into pulmonary arterioles, which becomes pulmonary capillaries. The pulmonary capillaries are wrapped around the alveoli. Right now, at that point, when the deoxygenated blood is passing, that's the point that oxygen reaches the alveoli and diffuses into the pulmonary capillaries. And then it becomes oxygenated. So the pulmonary capillaries have a deoxygenated side and an oxygenated side. You understand that concept?
Yes, sir. I understand.
Right.
Yeah.
And it's the same process from the systemic side. So you have the pulmonary circulation, I have the systemic. The pulmonary circulation is the circulation of blood from the heart to the lungs and back to the heart. That's what we call the pulmonary circulation. The systemic circulation is the circulation of blood from the left ventricle to the rest of the body and the return of that blood to the heart. So when the blood leaves the left ventricle and goes up into the aorta and is transported to the rest of the body, it's going to go to systems within the various areas of the body. And the systems have systemic arteries. These systemic arteries will become systemic arterioles, which eventually breaks down to systemic capillaries, right? Which are at that level, the exchange will occur. So the cells will then pick up the oxygen that it needs and give off the CO2, and then the CO2 is transported via the systemic capillaries, which will eventually form the systemic venules, which eventually become systemic veins, and eventually form the Vena Cava. Now, a lot of what I'm saying now, you might not be able to add it up in your mind, but it will make more sense tomorrow when we have the diagram and follow the flow of blood. Go ahead, Mr. Graham.
Yes, again, sir. So the coronary artery, where exactly does that artery come from? Because I know it supplies the heart, which is a muscle, with blood. So with oxygenated blood, that is. So
I actually mentioned this earlier, but okay. The coronary artery originates from inside the aorta. So that's where it originates from. So it originates from the aorta and it comes down to the anterior portion of the heart and it wraps around the posterior. So it originates from the aorta. Any other question? All right. Okay. So that's the vessels. And go ahead, Mr. Joe.
So would it be safe to say that it originates from the descending aorta?
No, I wouldn't say that.
Okay, understood.
Right? So I'll explain it more clearly tomorrow, but basically what happens is, and it's hard to explain without a diagram. Hold on. Let me. All right. So let's say. All right. So that's the aorta, right? And the blood that goes up into the aorta is coming from the left ventricle. Is when the left ventricle contract, it pushes blood into the aorta, and the aorta has an arch, so it kind of stay like this, and then you have something going up, a portion going up, right, somewhere up there to the upper body, and then it comes down, and that would be the descending portion, right? So let me use my pointer. This portion up here would be the ascending portion of the aorta, and then this portion down here would be the descending. This portion on this side is where it originates from, right? So the left ventricle contracts and pushes the blood up into this area. It goes over the arch, and then it goes up and goes down. The coronary artery originate from in this space. So there is a valve inside the aorta. So let's say the valve is about here. Pencil, need my pencil again. Let's say the valve is right here. So when the blood flows into the aorta, the valve closes. When the valve closes, there is a backflow of blood. So there's a backflow of blood, and that is the blood that will fill the coronary artery, which supply the heart muscle. Don't know if that makes sense, right? So when the left ventricle pumps the blood through the aortic valve, the valve closes, and then there's a backflow, and that fills the coronary vessels, which originate from that area. So it's not the descending portion, right? It's actually the origin of the aorta. Who was it that asked that question? I think it was Mr. Jones. Was that any clearer? Mr. Jones? Okay. So the truth is the coronary artery does not fill under high pressure, right? Body is so unique, right? Even though it's a high pressure, the arteries are high pressure vessels, the coronary artery actually doesn't fill under high pressure. It's laminal flow, so it's a backflow when the valve closes inside the aorta. All right, let me get rid of this diagram, and then I can move it. Let's move it in pieces. I don't want it close to that. All right. So let's review. Let's review. Let's see if you have learned anything. The brain might be a bit slow because you all had a heavy meal. But anyway, let's see what you have learned. Now with the composition of blood, what is the blood composed of? If you have an answer to that question, raise your hand, go ahead. Composition of the blood. Go ahead, Mr. Duhaney. Go ahead. What is the blood composed of?
Plasma, white blood, blood cells being white blood cells and red blood cells, and it just did it in my head, you know. Damn, sorry. White blood cells, plasma, and platelets.
Good. All right, good. That
Platelets.
would be correct. So the composition of the blood, you have your white blood cells, red blood cells, plasma, platelets, right? White blood cells, leukocytes, red blood cells, erythrocytes. Mr. Graham, what is the main role of each of these components?
Okay, sir. So starting with the platelets, it's mainly for healing or clotting of the blood. White blood cells for fighting diseases, bacteria. Red blood cells carry oxygen and non-oxygenated blood around the body. Oxygen and non-oxygen or carbon dioxide away and to the body. And the plasma is basically the host of all those stuff. So the plasma is just a liquid where all the essentials flow through, basically.
The plasma is the liquid part, so it's responsible
Yeah,
for transporting the component.
transporting the components. Yes, that's right.
All right, that's good enough. All right, so that's the composition of the blood. All right, we're going to backtrack a bit. What is the role of the epiglottis? The role of the epiglottis. Nope. Miss Beckford, go ahead. Go ahead, Miss Beckford. Roll out the epiglottis.
Are you hearing me, sir?
Yes, even though you sound very low, but go ahead.
Okay. The epiglottis falls backward to prevent any liquid from entering the larynx. Is it that I think?
The trachea or the larynx. I hear you.
Trachea, sorry, the trachea. My bad.
That's fine. All right. That's good enough. That's good enough. Now, what is referred to as the nasopharynx? Straightforward question. What is referred to as the nasopharynx? Any takers? Go ahead, Ms. Roxburgh.
It's the upper part of the pharynx connecting the nasal cavity.
The nasopharynx?
The nasopharynx?
Mm-hmm.
Would it be the upper part of the pharynx?
The upper part of the pharynx. I'm not comfortable with that answer.
The upper.
Not comfortable with that. Go ahead, Mr. McCoy. Go ahead. Nasopharynx.
Nasopharynx have something to do with warming air, filtering the air.
All right.
Allowing air alone to pass, but not other outputs. Okay.
No, that's
All right. Hold up a sec. So just hold on a sec. Hold it down. Now, this is very important. Somebody's mic is on. Hearing somebody's mic. Whose mic is on? Okay. This is very important. When you're asked a question or you read a question, you need to understand what the question is asking, right? So anytime you read a question or you hear a question, process the question and try to figure out what the question is asking. Question was, what is referred to as the nasopharynx. The question was not, what is the function of the nasopharynx? Go ahead, Mr. Roberts. Go ahead.
You hear me?
Yes, I can. Go ahead.
Hello. It's the, I think it's the upper part of the throat that's behind the nose.
That sounds kinda like it. It could be a little more smoother, but you're on the right path. On the right path. It is, the answer is pretty straightforward. It is the posterior portion of the nose. That's it. Right? It's not a complicated question. It's general knowledge. With that said, let me ask this question. What is the pharynx? What is pharynx? Miss Fenton, because I'm not hearing some people, so I'm going to start picking people now. Miss Fenton, are you present or absent? Not hearing anything, dear. One more time. Miss Fenton, are you present or absent? All right, moving along. What was the question? What was the question I asked just now? Oh, what is the pharynx? So that's the question. I don't want persons who have already answered. There is 30 persons currently in the room. I do not intend to only take response from 5 out of the 30. There are other persons in the room. I would like to hear what it is that you're thinking and what it is that you have understood up to this point. Mr. Sewell, present or absent?
Present and Tola, sir. I'm here.
All right. What is the pharynx?
Don't know at this time, sir.
All right, noted. Moving along. Mr. Card. Present or absent? Not hearing that person. Okay. Mr. Innis. Not Ennis. Innis. Present or absent?
Present, sir.
All right. So there's a lot of feedback there. That's not going to work for me. Moving down the line. Mr. Edwards. Present or absent? All right, not hearing anything at that point. The mic is open, but I can't hear you. Okay. Mr. Douglas, present or absent? Interesting. All right. So we need to do a roll call then. All right, so let's start back from the top. Let me stop my recording that I can focus.